All right, guys, our goal in section 3.3 is we are going to apply the principle of Cpctc, which you don't know what that stands for yet, and to recognize some basic properties of circles, okay? So starting with, I don't like that color. Starting with my first goal, we see right here. So if we know that the triangles are congruent, what else can we say? Okay, so let's say we're given these two triangles, right? And I ask you guys, are they congruent? And you would happily, after section 3.2, say, yes, these triangles are congruent. I know that angle A is congruent to angle D, even though it doesn't look like it. I know that an included side, AC, is congruent to, that should have two tick marks, ED. And then I also know that angle E is congruent to angle C. Okay, so because I have this information, I have an angle, I have the included side, and I have the next angle. So I know that these triangles are congruent, right? I have three pieces of information, and that is enough. So I can say that triangle ABC is congruent to, and again, watch how you name it. You guys can use colors if you want to. So this one has two tick marks, this one has two tick marks, this one has one tick mark, this one has one tick mark. It's easy for you guys to name the triangle if you kind of color the vertices of the angles like this. Okay, so I chose the pink one, and then I went to the green and the orange. So do the pink, the green, and the orange. So ABC is congruent to triangle DFE. Okay, once we know they're congruent, can we say anything else? Do we now know that angle B is congruent to angle F? Because it didn't say that over there. It did not say that. But do we know that? Absolutely, we do know that. We know that if the triangles are congruent, then all of their parts are congruent as well. And that's where Cpctc comes in. Once you have proven the triangles are congruent, you can finish pulling out the rest of the six pieces that are also going to be congruent. So far we have three pieces of congruence to prove the triangles are congruent. After you prove they're congruent, you can pull out three more pieces of information. The reason that B is congruent to F, well, we'll get to the reason in a second. So we know that B is congruent to F, and that takes care of all the angles. So now we have two more pairs of sides. We have BC would be congruent to, I have green and orange, so EF. And the last one would be AB, pink and green, would be congruent to DF. Okay, so those are the six pieces. First, we had to prove the triangles congruent. Once the triangles were congruent, then we could pull out the rest of the parts. So in your proof, the reason that angle B would be congruent to angle F, let's say, would be because if triangles are congruent, then the corresponding parts are also congruent, okay? If triangles are congruent, then the corresponding parts are congruent. Okay, Cpctc, this is what it stands for. Cpctc. Corresponding parts in congruent triangles are congruent. Corresponding parts in congruent triangles are congruent. Corresponding parts in congruent triangles are congruent. Okay, I have all those words right there. I like the if-then form better. You cannot put Cpctc. You can say corresponding parts in congruent triangles are congruent, or you can say if triangles are congruent, then their corresponding parts also have to be congruent, okay? So once we proved, because of these three pieces of information, we proved the triangles were congruent to each other. Once the triangles are congruent to each other, we can pull any other piece of information out that we need to use, okay? Second, so remember our second goal up here? I'll highlight it in a different color. that was recognizing some basic properties of circles. So we're moving on to circles. So the first one is, how do we make a circle? So the way that they would actually make a circle is taking the same distance and swinging it around the center so that the distance from the center to any point on the circle is exactly the same. So let's say this was 5 centimeters. This has to be 5 centimeters, 5 centimeters. They swung this 5 centimeter string around with a piece of chalk and they drew the circle. Okay, so that's how a circle is formed. The distance from the center is the same from every point on the circle. Okay, how do we name a circle? So if I'm referring to the circle at the right here, I would call this circle B. Okay, that means that B is the center of the circle, and that's important because now if I connect B to C, I have a part of a circle. Okay, so it's important. I would call this one above it circle A. Okay, so I have circle A, circle B. You should know which circle to refer to, and you also know where the center is then. Okay, so for part C, I'm going to tell you we have circle C, which means C is the center. If I did not know C was the center, I couldn't assume that ED is the diameter. But because it goes through the center of the circle, I know that ED is the diameter. I also know that EC is a radius, and another radius would be CD. Okay, a radius is half the diameter. So if this radius is 7 and this radius is 7, the entire diameter would be 14. So diameter is equal to twice the radius. Okay. Formulas for a circle. Area of a circle is pi r squared, and the circumference of a circle is 2 pi times the radius or pi times the diameter. Okay, so if I was looking at the circle on the right, I would say it's pi 5 squared, or make it look pretty and say it's 25 pi. We usually leave it in terms of pi. The circumference for this is going to be pi times the diameter, so 10 pi. Okay, again, here's your diameter. This other piece is 5, so the diameter is 10. And then the last thing we need to know about a circle is we are allowed to use this theorem. All radii are congruent. You are allowed to draw radii. So you guys are going to be getting to some proofs, and you may want a line where there is no line. So you're allowed to draw the radii. So we can draw any 2 points, make a line. Okay, I can draw this radii right here. And I'm allowed to say in my proof that AE is congruent to EB. And the reason is because all radii are congruent. Okay, of course this should be called circle E. Okay, we should be given that this is circle E. If you see a circle with a little s in it, that just means circles, plural. Okay, the little s means circles, plural. And that is it for section 3.3. We will do these 2 proofs in class on Friday.